Alright guys, welcome back. This is EKG Plain and Simple. We're going to be covering Chapter 5 today, which is calculating the heart rate. So the heart rate is very important of EKG because it's going to tell you how the patient's presenting. A lot of treatments are associated with the heart rate. There's a lot of medications they give that's associated with the heart rate. So it's kind of important we get this correct and get a good idea of what the heart rate is. So the heart rate, how do you figure it? The heart rate, when we say you have a pulse rate of 60, what we're saying is on a QRS or on a EKG strip, you have 60 QRS complexes per minute. So every time you feel your heartbeat, you feel a pulse, you feel that little thump from the pulse rate, that is a QRS complex. So when we look at a rhythm strip, we're counting the QRSs per minute. That's what we're trying to accomplish. Now, remember when we were looking at the EKG rhythms, you have your P waves and then you have your QRS complex, right? Sometimes you'll have more Ps than QRSs, and sometimes you'll have a different ratio of Ps to QRSs. When we talk about the heart rate, we're referring to the QRS complex is what we're looking for. This would also be the same as the ventricular rate. There is an atrial rate that you'll hear people refer to. Atrial rates refer to the P waves per minute. So if you have a rhythm such as atrial flutter, you have more Ps than QRSs. So there you would have a ventricular rate, which is the QRSs, and an atrial rate, which is the P waves. But typically, though, when we say you have a heart rate of 60, what we're referring to is the QRS complexes and the physical beat, that little physical pulse beat that you feel every time the heart beats. So a couple methods to check the heart rate. The first and the most easiest one, we talked about this a little earlier in class, is the 6-second strip method. And what you do there is you get a rhythm strip that consists of 6 seconds. And you look at it, you count the QRSs in that 6-second strip and multiply by 10. Kind of basic, simple math, right? Because 6 seconds, you have 60 seconds in a minute. So 6 divided by 60 is 10, right? So you have 10 6-second strips in 1 minute. So when you count the number of QRSs in one 6-second strip, you multiply by 10. That will give you the mean heart rate of what it should average out over a minute span. Now, this is a pretty decent method if the patient's stable, the heart rate's not changing, it's staying pretty consistent. You can do this and get a pretty good idea of what the heart rate is. Some of the more sick patients, though, the ones that have the heart rhythm issues, you may not get a consistent heart rate, so this method may not be the best method to calculate the heart rate. So why is it important to get a good heart rate? Okay, so the treatments, a lot of the treatments for heart rates and a lot of treatments for cardiac issues is based on the heart rate. If you get a really sick person and they have a heart rate of 30, and you get the same person with the same symptoms of a heart rate of 230, the treatment's going to be a lot different. There's a lot of different medications they give, a lot of different processes they do, and then the heart rate has to do with what type of rhythm it is. So it's really important that we get a correct heart rate and get a good idea. When you're looking at heart rates, it makes more sense to provide a range of rates opposed to a specific number. Like, for example, if you walk into the class, you walk in through the door, and as soon as you get in the door, you've walked across the parking lot, you walk through the building, you've moved quite a bit, and you check your heart rate, you might get a heart rate of 100 or 110 or something like that. That might be normal because you've done quite a bit of activity and moving around. Once you sit down and you sit there for a while and you relax and your body kind of calms down, you might have a resting heart rate of 60. So there's a difference of 40 to 50 beats a minute. So treatment-wise, if you had a heart rate of 110 and you were sick, opposed to a heart rate of 60 and you were sick, that's two different treatment methods that you're going to do. So that's why it's good to get, when you're looking at heart rates, try to get a range of the heart rates. What they call a mean heart rate, MEAN, mean heart rate, what we're doing there is we're getting it's kind of like an average, right? We're saying, all right, so the heart rate was 60, then the heart rate was 80, then we're back to 60, then we're back to 80, so the mean rate would be 70, what's in the middle of it there. Okay, so when we look at the rhythm strips, trying to get the calculate the rate. Right, so this is both with a mean rate of 50. Right, so when we look at both these rhythm strips, they look a lot different, A and B. But if you look at them though, and you actually calculate it, they both have the same heart rate, a rate of 50. Right, so if we're looking at it, this is a QRS here, QRS, QRS, and QRS, and then here's one, right? So we got 1, 2, 3, 4, 5. So it's 5 QRS complexes in a 6-second strip. So he has a heart rate of 50. Now if you look at the one at the bottom, we have 1, 2, 3, 4, kind of close together, a big long pause, and 5. Right, so again, we have a heart rate of 50. These two rhythm strips are two totally different rhythm strips. They have two totally different sequences of QRSs. They're both very irregular, but they both still have a heart rate of 50. So another method for counting the heart rate is the memory method. There's not really a simple way of doing this other than just memorizing it. So the memory method, it's widely used in hospitals. It's the fastest method of calculating the heart rate for a very specific portion of the QRS. It's based on the concept that there's 300 big blocks every minute on an EKG strip, 300 big blocks. So you count the number of big blocks between the consecutive QRS complexes and divide that number by 300. Memorize this sequence of numbers: 300, 150, 100, 75, 60, 50, 43, 37, 33, and 30. Okay, so if we get those numbers, those are all increments of that 300. So this is how the 300 method translates over. So when we're looking at the rhythm, if there was number of big blocks between the QRSs, so if we only had one big block in between each QRS, they're going to have a heart rate of 300. If you counted it and there was 2 blocks, they're going to have a heart rate of 150. 3 blocks, heart rate of 100. 4 blocks, 75. 5 blocks, 60, and so forth, all the way down to, it's calculated down to 10 blocks. If you counted 10 blocks between each QRS, they're going to have a heart rate of 30. Right? So this method is pretty useful if you're trying to calculate really quickly what's the heart rate and you're looking at a very specific part of the QRS. The downside of this, though, this does not give you a mean heart rate. This actually gives you a specific heart rate between one QRS to another. So if the heart rate's varying, going up and down quite often, this is not going to give you a really accurate heart rate. But if your rate's pretty consistent, though, this will give you a really quick method of calculating the heart rates for you. Okay, so the next method is the little block method, right? The one we just talked about was the big blocks. This is the little block method. Now, this one gets a little more mathematical, so you might have to bring out your calculators or something to do this one, but here's the way it works. You count the number of little blocks between each QRS. Divide that into 1,500 because there's 1,500 little blocks in a minute. So when you're looking at the EKG strip, those little tiny boxes in there, that 0.04 of a second box, there's 1,500 of those in 1 minute of a strip. So if we count the number of blocks, divide that into 1,500, that will give you your rate. And the way you do this, use this a lot with irregular heart rates. If the heart rate's very irregular, where it's speeding up and slowing down, kind of like those rhythm strips we just looked at, you would find 2 consecutive QRS complexes that are the farthest apart, and then you count the little blocks, and this is going to be your slowest rate. And then you find 2 other QRSs that are the closest together, and you count the little blocks. That's going to give you your fastest rate. Now, to get a mean rate, then you can take those 2 numbers, then add them together and divide by 2 and get an average, and that'll give you an average of the heart rate and a pretty close mean rate. All right, guys. So this little strip here, this is a normal, regular rate rhythm. It's a sinus rhythm. You can use this to practice a couple of different methods of how you want to count them. Right, and we were just talking about the 6-second strip. If you want to count that method first, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I see 13 QRSs, right? And this is a 6-second strip. 13 is going to give you a heart rate of about 130. The other method, these are the big blocks that we're talking about. You can see this little area, if I can get it to highlight right here, this little area right here, that is a big block. So we got 1, 2, 3, 4, right? This is how the big blocks go. So to do the big block method, you want to kind of find one that falls on a block. So this one right here, if you notice it starts right on the start of the block. So I've got one big block here and 2, and it finishes up on the second. So we got 2 big blocks. So then you'd use the little chart and you'd calculate that out. And it should come up to about 130 also for you. The third method is the tiny little blocks, and again, same concept, and then you would sit down and you would count these. So 5 little blocks is this one, and then 5 little blocks makes 2, right? So you got roughly 10, maybe 11, 10 and a half little tiny blocks. Divide that into 1,500, gives you about a rate of 150. So there's a little bit of variations in there. Depends on what method you use. Specifically, this particular one right from here to here, using the little block method, this little area here, that calculates to about 150. If you do the 6-second, it calculates to about 130. It's because every QRS here is not exactly the same, so there's a little bit of variation. So you can kind of see the purpose of this was to kind of see that there is a little bit of difference. The more detailed and more specific that you get on the rate, like you're measuring between one QRS to another QRS, the bigger variation you might get. So if you do the whole 6-second strip and look at it as a whole, as a big picture, you're going to get a rate of 130. But if you're calculating individual spaces in between each QRS, you might get a rate of anywhere from 120 to 150. Kind of depends on which particular one you're looking at. But as a whole, though, it's 130. So hope that kind of helps you calculating the rates and understanding the process there. Okay, so you're going to hear this term regular a lot, right? And you'll hear it referred to as regular, irregular, or regularly irregular, and so forth. But when we talk about regular, what that means is it's consistently beating at the same rate. Now, with a heart rate, there's always a little bit of variations in the number. You might be just plus or minus one little block off one way or the other, but you're going to be really close to what it needs, really close to consistently the same on a regular rhythm. So heart rate calculations are typically based on regular-based rhythms, right? It means that the rhythm is consistently the same number. Rhythm regularity is concerned with the spacing of the QRS complexes. So when we say that a rhythm is regular, we're talking about the QRS complexes are consistently the same distance apart. And the way that you measure the QRSs is you look for the R to R intervals, right? That little top peak. When you're looking at the rhythm, you got that little sharp peak and this little tip up here, that's the R, the top of the R. That's what we're looking for. So we're measuring from one R wave to the tip of the R wave to the next tip of the R wave, peak to peaks. That's how we determine if the rhythm is regular or not. Not looking at the P waves, not looking at the start of the QRS or anything like that. We're looking at the peak of the R waves. And again, go from the spike, the tip of the little rhythm to each tip. So a regular rhythm, R to R intervals may vary by only 1 to 2 little boxes, right? So when you count that out, you might get 5 little boxes between one rhythm, and then you look at the next QRS, there might be 6 little boxes. You might look at the next one, there might be 4 little boxes, but the baseline is 5. It seems to be the average, and there's no variation more than 1 to 2 little blocks. If there's more the variations of 1 to 2 little blocks between each QRS, then the rhythm is not considered regular. Also, when you're looking at the QRSs, they should look very much similar. You might, again, have a little bit of variation in the QRSs, but they should look very close to being the same thing. All right, so this little guy here, this is a typical rhythm strip that you're going to see. He's got some other underlying issues going on that we'll talk about later, but his QRSs are inverted. So the tip is down here at the bottom that you see down here, and that's what they're looking at is these little spikes coming down here. Okay, and so when we're looking at this little rhythm, there's one more right here on the end. When we're looking at these little rhythms, they've counted the boxes for you. This particular one from this tip to that tip was 23. The next one was 23. The next one, 23. 23. Here's 23 and a half. 23 and a half. And then there's a 24, right? So there's not very much variation, one box difference. So this would be a regular rhythm, right? He's got some other issues going on. Like I said, we're going to talk about that later, but the underlying rhythm is regular because it beats on the same speed. So then, once you get a regular rhythm, the next step up when we start having little problems is irregular but interrupted. These are regular rhythms that are interrupted by premature beats or pauses. So when you look at the big picture, the big 6-second strip, everybody looks normal, but you got this one little random misfire, this little random thing that doesn't look right. Either the space is a little bit longer than what it should be, or the QRS doesn't look like everybody else. So there's something unique about it, but it's only like one little spot. So that would be a regular rhythm with some type of interruption in it. What they usually call like premature beats. So when you look at it really close, you'll see that there's only like one or two little beats like this. There may be a little burst of them, like maybe 3 or 4 little beats in a little cluster, but then it goes back to its basic underlying rhythm. The R to R intervals are regular until those beats pop up, and then once the beats go away, then the R to R intervals should return back to the normal rate of what it was before. So this is where we're kind of finding the underlying rhythm compared to the premature beats that falls into it. So your underlying rhythm would be the regular rhythm, and then your premature beats or your pauses is the little interruptions in it. So when we look at this little rhythm, just kind of eyeballing it, not bringing your calipers out, you can kind of see there's a beat here, here, right, and we're looking at these little tips right here is what we're counting. And we're counting this. And actually, you could count this one either way. You can count the bottom down here, too. It's going to give you the same numbers. So we're looking at the little spikes, right? We got 15, 15 and a half, 15 and a half, 15 and a half, 11, 17, 16, 15, 15, 15, 15. So from here over and from here this way, right, so the first half, all this through here was normal. All this over here is normal, and all these are regular. And if you look at the left side and the right side, those beats are the same if you compare the left side to right side. But this little group right here in the middle, though, they're a little bit different. You notice there's one, he's a little early, right? They're normally 15. He came in a little early. He came in at 11. And then after he came in, then there was a little bit longer pause. There was actually a pause up to 17, and then there was a 16, then back to 15. So what's happened here is you've went a nice little smooth rhythm. For some reason, he's had a premature beat, which is that one's come in here at 11. Somebody come in here a little early. And then when he came in early, the heart's like, hey, there's something going on. So it took a little bit of a break. It paused for a little longer than normal, trying to get everybody back into sync, back into rhythm for itself. And then it waited 17 blocks, and then it had a beat, and it said, well, this ain't right. Then it waited 16 blocks, then it had a beat, and then it finally got back into the 15-block rhythm back to where it came from. So the heart had a little bit of a hiccup. It kind of regulated itself and got itself back on track. So this is where you find that little abnormal beat, this little part that's not regular, and they call these premature, right? Premature beats, because this is, if you're looking at the rhythm, this was 15 here, this one here is 15, so this one should have been 15 here, but it was actually 11, so it was early, so therefore it was premature, right? It hadn't matured and hadn't got to where it needed to be, so it was a little bit early on it. So that is what they call a premature beat. All right, so here's another one. This is a regular rhythm interrupted by a pause. And again, if you look at from here over to the left, and then from here over to the right, you have 25, 25, then you have 26, 25, 26. So these are all regular compared to each other. But right here in the middle, you have a 43 space, right? It's went 43 blocks before that came in. So there's nothing going on here. It's just dead space, dead air, nothing's happening, a little flat line going on. So that is what they call a pause. So this is a regular rhythm with a pause in the middle here, right? And then after we get on down the road, we'll determine what kind of pause this is. But just understand over here, when we refer to a pause, that's what they're talking about. It was a regular rhythm before, had this little stretch of nothing, and then goes back into your regular rhythm. Okay, so now you're saying, hey, well, if it's not regular, how am I supposed to calculate the rhythm of that? You know, if it's not beating consistently, how am I supposed to figure out what the rate is? It really depends on what particular part of the rhythm you're looking at. Well, you're absolutely right. So when you're trying to calculate a rhythm, you want to look at the R-to-R intervals throughout the strip. If there is no pattern, if there's no rhythm to it, then that's going to be an irregular rhythm. The next thing you want to figure out is, now that there's inconsistencies with the rhythm, is that because of a premature beat or a pause, or is the rhythm just irregular altogether? So if you look at a 6-second or maybe even 2 or 3 sets of 6-second strips, you might have to look at it for the whole minute maybe. If you don't see a pattern or a rhythm, then that's going to be an irregular rate. But now if you look at it and the first 10, 15 seconds is nice and smooth, and then you have a little stretch of 6, 10 seconds that are not regular, and then it goes back to a nice smooth rhythm again, then your underlying rhythm is going to be where it was regular. Right, so you want to look for the regularity first and try to find a regular rhythm. But if you can't find a regular rhythm, then it's going to be an irregular rhythm, and it's going to be very, very hard to come up with an accurate heart rate on an irregular rhythm like that. All right, so this is a irregular rhythm, and if you look at this rhythm, you can stare at this rhythm all day long, and because of his underlying conditions, he is never going to have a regular rhythm, right? His QRSs that you see here, they're always going to be spaced out differently. They're always going to have different spaces in between them, right? We got a 17, a 20, a 30, 11, a 21, a 13, and 18, and it'll keep going that pattern. There'll not be ever a time when you get a stretch of regular QRSs. So this, by definition, is going to be an irregular rhythm. So then once you determine that the rhythm is regular, once we get farther into it and we're figuring out what rhythms there are, we can use that. Then we'll add a few more words to it to determine what's causing that irregular rhythm. So these little strips coming up, there should be some practice strips here. These will also be in your book. You can look at the rhythm strips, kind of identify it. You know, are these strips regular? Are they irregular? Are they regular with a pause in it? Are they regular with a little misbeat in it? And if you look at this one here, and just kind of looking at it, the QRSs look the same. If you measure the distance, though, I don't really see a discernible pattern to this, right? If you measure the distance between each one of them, you're going to get different numbers every time you measure the distance. So this is going to be a irregular strip, irregular rhythm. This guy, what do you think about this one? Right, so I've got 3 little QRSs, right? So it's going to give them a heart rate of 30. If you measure out the distance between here and here, right? Measure this distance out. It's going to be really close to the same distances from here to here. Okay, so that it's going to be a very slow rhythm, but just the fact that you have the same distance between each QRS, then that is going to be a regular rhythm, right? It's a very long rhythm, but it's a very slow rhythm, but it is regular though. So what about this guy? What do y'all see here? All right, so we have QRS, 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 and here. Right, so these up to this point right here, as we're going over, that looks to be regular, right? And you can get your calipers out and measure this, but it should be very, very close to being the same as you go across. So this part, when it first starts off, that is a regular rhythm. And now looking on the back side of it, from here this way, those again look to be very regular. And if you compare the left side, you compare this side to this side, they look very similar, right? The distance is the same. Get your calipers out, and again, you can measure these. They're going to be very close. This one right here might be a little bit longer than the rest of them. We're just getting back on track. But this little guy right here, this little section right here is not correct. If you look at the distance here between these two, this distance is a lot shorter than the distance it was between these and all these over here. So this little guy right here, if you can see him right in the middle, he is a premature beat, right? He came in early. He came in too soon. He was before when he should have been. He should have been somewhere like right in here, but he fired too early, so therefore he is a premature beat. So this would be a sinus rhythm with a premature beat in it. Alrighty, so what about this guy? QRS, QRS, QRS. Right, we're all in agreement that the first three beats look about normal. Does everybody agree with that? So after that, then if you look at these last two little beats, compare these last two beats together, these two guys, they look pretty much similar, and they look a lot like the first ones over here, right? So they look good. But the question is this section right here, right? You have this big long area that they should have been, if you measure it out, take your calipers, measure out from this beat to that beat, and then you should have had another beat right about here somewhere. There should have been another QRS in that area. So because we didn't have a QRS where they should have been, right, if you measure the distance from here to here and then go from here to here, there should have been a QRS right here somewhere. And since there was not a QRS there, that is considered a pause because there should have been something there, but it didn't show up, so there was a pause in the rhythm. And then it picked back up over here. Under this one, it picked back up under its normal rate. So it's just, it beat, 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 and then all the electricity shut off for a second, it paused for a little bit, and then picked back up where it left off. All right, so what about this one? I see one big guy jumps out here, right? The elephant in the room, this little fella right here. So if you look at these all look pretty good. If you look at these all look pretty good. But you've got this one little guy right here he just doesn't belong. He doesn't look like anybody else. So that is not your normal QRS, right? And he's very obvious. He stands out. He's very clear that he's very different than everybody else. So that is a premature beat because he fell in early than what he's supposed to be, and he just don't look like anybody else. Okay, so when we're trying to calculate the heart rate, there's a couple ways to do it, depending on the rhythm first, right? The question is the rhythm regular or is it irregular? For a regular rhythm, we can use, you pick out any two QRSs. If the distance is the same between everybody, it doesn't matter. Just pick any two QRSs. You can use the little block method. You can use the memory method. If you want to use the 6-second method, it works great too. Pretty much any method you want to use to calculate this, it's going to be pretty accurate if all the QRSs are the same distance. Now, if it's irregular, meaning that the rate is going up and down, is varying, and you got differences in the QRSs, then you're going to have to figure out mean rate. You're not going to be able to come up with a specific number. You're going to say, well, the average heart rate is this, because sometimes it's slow, sometimes it's fast, but the mean rate, the average rate between all of them. So a lot of times this is where the 6-second method comes in really good. You're going to look at a 6-second strip, count the number of QRSs in it 6 seconds, multiply that by 10, and that'll give you a pretty good estimate and a mean heart rate, right? The mean rate of it. All right, so how do we figure a heart rate if you've got one of those little premature beats, right? A little beat that looks different. So when you're calculating the rate, you're looking at the strip, you see the QRSs, and you've got that one guy that he just don't look right. He just doesn't look like anybody else. Well, when you're calculating the heart rate, ignore the premature beats. So if you've got a beat that's not there like it's supposed to be, he doesn't belong, don't count him when you're counting your heart rates. For example, here, when we're counting this heart rate, this little guy right here, he does not belong. He doesn't look like anybody else. He just hopped on the bus. He shouldn't be there at all, right? So when we're calculating the heart rate on a 6-second strip like this, we're going to count 1, 2, 3, 4. He doesn't matter. 5, 6, 7, 8, 9. So the heart rate here would be 9 in a 6-second strip, which equals to 90 beats a minute, right? So his heart rate would be 90. Even though if you look at it, you have 10 QRSs in here, but this little oddball here, he don't belong, so he don't get counted. So only 9 QRSs are supposed to be there, so the rate would be 90, 90. Here, regular rhythm interrupted by a pause. Again, when we're counting the rate here, we would not count this pause, even though there should be a beat in here, right? But it's not there, so we don't count it. So we got 1, 2, 3, 4, 5, 6, 7. So 7 beats, 7 QRSs, heart rate is 70. So even though probably after this, when he went back to his normal rate, he would probably really have a rate of 80 because you're going to have a beat in here normally. But at this particular moment, looking at this particular strip, we have 70. So kind of heart rates to calculate for different types of regularities. If it's regular, one heart rate, you get a particular number. If the heart rate, if the rhythm is normal, regular, consistent, you're going to get a number. If it's irregular, you're going to get a range of rates and a mean. So, like if you get somebody who's got a heart rate that varies up and down, when you report that out and you chart that, you're going to say a heart rate between 60 to 80 with a mean rate of 70 or something like that. So let's look at these little strips. Let's calculate these heart rates. All right, this one's very busy. If you notice, the P waves are odd shaped, right? So we have a lot of busyness going on here. But if we're calculating the heart rate, we're going to count the QRSs. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? So 10 QRSs, a 6-second strip, 10 times 10 should be a rate of 100. Right? You can use that method, or you can actually, since this is a pretty regular rhythm, you can also count the little boxes in between, and that should give you something pretty close to that also. So when you're looking at these strips, practice both methods. Practice the 6-second method where you're counting like we just did. Also look at the boxes, count the boxes, get used to counting the boxes and calculating it that way also. Again, here we go. 1, 2, 3, 4, 5, 6, 7. Right, so it should have a heart rate of about 70. If you count the little boxes in here, you might get a little bit of variation from that number, but it should be really close to it. So again, try to practice that. And the reason I keep saying practice the little box method, because it looks like it's very simple just to look at a 6-second strip and count the beats and then you count them up and you got 7 beats, so the heart rate's 70. But sometimes you might not have a full 6-second strip. Sometimes you may only have a 3-second. You might have a 2-second. You might have just a little snippet of a rhythm strip. So you may not have that full 6 seconds. So you need to be able to calculate the rate no matter if you have a 6-second or not. So if you have a full 6 seconds, that's great. But if you don't, though, be familiar with the box method too, so that way you can count that up. Here, again, when we're counting this little guy, remember this one you do not count, right? He's a PVC. He's a very different shaped QRS. So we're going to go 1, 2, 3, 4, 5, 6. Don't count him. 7, 8, 9, 10. So you should get a heart rate of 100 for this one, right? Because we're not counting this guy right here. Don't count him at all. All right, this one's just a little bit irregular. Just by looking at it, I see a little bit of irregularity right here in this little section. You see the distance right here is a little bit longer right here than it is over here. So the box method may not be 100% accurate here. So you want to count the QRSs on this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I got 14 QRSs, so he's going to have a heart rate of about 140. Next up, we got a little bit of a pause going on there, right? But we got 1, 2, 3, 4, 5, 6, 7. So I got a heart rate of 70. This one, give you guys a second to look at it. So it looks to be irregular, right? The distance between each QRS is varies on every one of them, looks like. So the measuring one QRS to another is probably not going to give you a good one. So this one you can do it two ways. Either you can do the 6-second method, count all of them, which will give you 1, 2, 3, 4, 5, 6, 7, 8. So it gives you a rate of 80 on the 6-second. Or you can measure the longest distance one, which is probably these two guys. Count the boxes, and then pick a short one. Let's say probably these two guys here. Right? Count the boxes. That'll give you two different rates. That gives you your fast rate and your slow rate. And then use those two numbers to get your mean rate, your average rate in between, which should be really close to what you got when you counted on the 6-second rule. All right, this got 1, 2, 3, 4, 5, right? Got 5 beats. They look a little, yeah, they look regular. Maybe if you get your caliper out from this one to this one, it might be a little bit longer than that, but they're pretty close though, pretty close to it. This one, you notice that the baseline kind of comes down and it dips a little bit here and then comes back up. That would be associated with some movement or something like that, like he's probably breathing or the patient's shifted weight or something along that lines. But kind of keep that in mind. You can see how the baseline drops a little bit on you here, though. This one, the QRSs come way up off the paper, right? He's very, very electrified, if you will, right? The gain is turned really high on this. When they were talking about the gain setting on your monitors, this one probably needs to be dialed down a little bit. A lot of the more modern, more fancy EKG machines will adjust the gain for you, but this particular one, though, he needs to be dialed back just a little bit to get him back on the paper. But if you look at this one is not regular, right? The distance between each QRS, it varies on just about every one of them. So using the box method on this one, you would need to calculate a short one, like maybe this one, and then calculate a long one, like maybe this one, and then add them together, right, to get your mean. Or you can do the 6-second method, which will give you 1, 2, 3, 4, 5, 6, or 7, right, about 70 or something like that, right? 70. So then when you do your box method, you should get something pretty close to that also. This one, make sure that these QRSs are not as defined with that little up, down, up method. It's more just kind of an up and done. But this is a QRS. There's your QRS. That one is a QRS. That one is. That one is. That one is. that one. I'm pointing these out for you because they kind of sort of look like the P waves or perhaps the T waves, right? And this one will really, when we get into the atrial and ventricular rhythms and stuff like that, it'll kind of help you define what's a QRS, what's a P wave, and what's a T wave, because these guys, they all kind of look the same. It's just the only difference is the height of each one of them. This is a very unique rhythm, and we'll get into that later. But be able to identify the QRSs here, and those are the tall ones, right? The tall little guys. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I count about 12 of those. So we're going to get a rate of about 120 on this. Alrighty, guys, and that is the end of that. Next topic we're going to come up with is the atrial sinus node stuff. That is the next presentation, and see you in class.